Okay, number 13, it says we're going to use this model to illustrate the following addition and subtraction parts from A through D. So we have 14, and then we have a length of 8 and 6. So the model we see is 8 plus 6 equals 14. So A says when 8 and 6 are put next to each other, it's equal to the same length as 14, and that represents that model. So we're going to say yes. Okay, B says 6 plus 8, so they've reversed the order. So we want to say when 8 and 6 are put next to each other, nope. If 8 and 6 are put together on top of 6 and 8, or 6 and 8, sorry, I can't read. If 8 and 6 are put together on top of 6 and 8 put together, they equal 14. Yes. So that's kind of reversing the order. This one says the same as we did in part 1. So you want to use your model to answer the question. This one we have 6 and we're taking away, we have 14 taking away 8. So C, take the length of 8 from 14 and the length of 6 is left. That represents this model. And then D, we have 14 minus 6 is 8, so we want to take away 6. And C says take away the length of 6. We're left with 8. Okay, and then 14, is there a non-empty set of whole numbers that's closed under subtraction? Okay, so whole numbers are the numbers 0, 1, 2, so on. Okay, if you pick any number, just let's say this one number, 1. If I do 1 minus 1, then it equals 0. So if I use 1, I also have to have 0. Now if I were to subtract these two, let's say I take 0, take away 1, I would have to have negative 1. Because I could subtract those in any order. I could do 1 minus 0 and get 1, but 0 minus 1 gives me negative 1. So this is not a whole number. So you can't just have one number that's bigger than 0. However, we could use 0. If I use 0, I can do 0 minus 0. That's 0. That's the only thing I can use. Changing the order doesn't matter. So this would be the only set that would work. So B says that